Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about queues. It is one more linear data structure. So before we start, a small information I'd like to share. In this channel we produce every video in two different languages, Hindi as well as in English. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. Till now, we have discussed about different data structures like array, linked list, stack, and this is one more data structure that is called queue. In this video, we are going to learn what is a queue and how to implement it using an array. Basically, we have seen a queue in every walk of life. When we stand in a railway station for a ticket booking, there is a queue. I don't feel that you need an example of a queue because every now and then we are experiencing a queue, and that same meaning we are trying to translate it in a computer system. For example, when we are using a computer, let us say taking a printout. So whatever print statement we are giving at the first, the same print we are getting printout at first. And the next print command, we are getting the second output. So whenever we are giving print command, it is in a printer spool, and from the printer spool, printer will be taking the statement in a queue. It means whichever statement appears at the beginning, at the first, it will be taking the printout first, then the next, till the end. Similarly, when system is doing scheduling, there also the system uses a queue. About different kind of queues we are going to discuss in our later on videos. Let us see the definition of a queue. So a queue is defined as a restricted list where the insertions are made only at one end, that is at the rear, and the deletions are made at the other end, that is the front. It means whenever somebody will be entering to the queue, it will be entering at the end of the queue, and whenever the service is provided, it will be deleted from the front of the queue. Before going to discuss in details about queues, let us see what are the different applications we are having. So queue is one of the most useful data structure in real world situation. Queue is useful in time sharing computer system where many users share system simultaneously. As I have told, for example of a printer or when CPU is getting scheduled. Queue is a solution of problem involved in searching, that is specifically breadth first search in non-linear collection of states. From here what you got? Basically, queue is a data structure, first in, first out. Those who are there in the queue at the earliest, they will be served at the earliest. So first in, first out. In short, we say it is a FIFO kind of data structure. Let us see what are the operations that we perform in a queue. So we add to a queue or insert into a queue. Let us say I and Q. I is the element we are inserting in a defined queue, and the element will be inserted at the rear or at the end. One more operation is delete queue. It means it deletes the element whatever is there at the front of the queue. Next operation is get front. It will just return what is the data available in the front of the queue. The next operation is empty. It means if the queue is empty, it will return true, otherwise it will return false. Similarly, is full. That every queue has a queue length. If a queue length is defined, obviously after the queue length, we'll say the queue is full. It will return true if the queue is full. So these are the basic operations that we are going to perform when we are implementing a queue. And queue can be implemented by using either an array or using a linked list. I hope you know what is an array and what is a linked list. In this video, we are going to say about how to implement queue using array. So even if you don't know array, stay tuned, watch the video till the end. You'll be understanding queue as well as array. So let us define using array. So we are taking a class called queue. We are having some private data, that is integer type of data. We are taking rear and front. We are taking a queue of size 50 and it takes all integer value. Two more variable we are taking. One is max, that is maximum capacity of the queue, and right now the size. What is the right now current size of the queue? And we are having a constructor. Initially we are defining size to be 0, maximum to be 50, front and rear to be -1. It means at the beginning there is no element in the queue. And these are the operations we are defining. Is empty, is full, we are adding an element, we are deleting an element, and we are getting the front of the element. Let us see how to implement it with example. So how a queue works, let us see with the help of this small animation. So let us say 1 is the element, it will be inserted to the queue, it will serve and it will be coming out, then 2 comes out, then 3, 4. So in this way the queue performs its work. Whatever comes first into the queue, it will be deleted first from the queue. So you can see here that this data structure is a first in first out data structure. Whatever comes to the queue at the beginning, it will be served first, and every element will be inserted into the queue from the rear and it will be deleted from the queue from the front. Let us see what is the basic operation that we are going to do when we are adding an element in a queue. So initially the queue is empty and front and rear is pointing to -1. It means the queue is empty. Now if first element come, we'll increment the rear by 1, and at the rear position the first element will be kept. When the second element appears, again rear will be incremented by 1 and second element will be kept in this particular location. When third element comes, similarly the rear will be incremented first and element will be added at the rear. Fourth element appear, rear is incremented and the element is added. Similarly, we are going to do the add operation or insertion operation in this way. So every time element comes, it will be inserted at the rear. Now let us try to understand this with the help of an algorithm. We are having, let us say, a function called add element, add to a queue, and the element we are entering, it is a integer data type. This element we are passing it as a parameter. Assume that the maximum size is 3 and the rear is pointing to -1. These are the basic assumptions. Now the first statement we are getting, if not of is full. It means the queue is not full. This condition is true. It means queue is not yet full. It is right now empty. So what I have to do? I have to increment the rear by 1. Earlier rear was -1. Now rear becomes 0. At 0th location, the first element 1 will be added. So in the queue, 0th element first value is equal to 1. Now size is increased by 1. It means the size of the queue is now 1. It contains only one data. Let us take one more element. Now rear is pointing to 0. If not of is full, it is true. Yes. Then rear is incremented by 1. When we are incrementing the rear, this value becomes 1. Q of 1 equal to 2. It means the second element we are adding at the first index. Now the size is incremented by 1. The size becomes 2. Let us try to add one more element. Maximum size is 3. Rear now is pointing to 1. So if not of is full, is it true? Yes, it is true. So what we are going to do? Rear we are incrementing and element we are adding at that particular location. So rear was 1, it is incremented by 1. So at the second index of the queue, element 3 will be added. So element 3 is added at the rear. Now size is incremented by 1. So maximum element is 3. We are having 3 elements. If I want to add one more element also, this condition, if not of is full, it becomes false. When it becomes false, it will come out and it can say we cannot add any more element to this particular queue. I hope you understood how to add an element in a queue. Now let us try to understand how the delete operation works. Now front is pointing to -1, rear is pointing to 5. So while deleting, what we'll do, we'll increment the front by 1 and the front location we are going to delete it. Again, the next element if you want to delete, front will be incremented by 1 and this particular location, whatever element is present, we are going to delete it. So this process we are going to continue till the end. It means front is equal to rear till front is equal to rear. So every time we are going to increment the front and we are going to delete the element. At this point, front is equal to rear, so we cannot delete anymore. Now we are going to see the algorithm how to delete an element. I hope from this particular animation you understood what we are going to do. Delete is the operation that we are going to perform and there is no parameter passed for it and the return value is an integer value. So we are going to check whether the queue is empty or not. If queue is empty, we are not allowed to delete the element. Otherwise, we will be decreasing the size and return the front of the element. Now you can see front is pointing to -1, rear is pointing to 2. This condition, if not of is empty, if it is true, yes, the queue is not empty. So what I have to do? Size will be decreased by 1. What we are going to do? Return queue plus of front. It means front we are going to increase by 1 and that particular location element we are going to return. Now front is pointing to -1. After front is incremented by 1, it becomes 0. So queue 0th element is 1, that will be returned. So this particular element is returned. So the next element if you want to delete, size is 3, rear is now pointing to 2 and is full. This condition is also true. Now size is decremented by 1, means after the execution we will be having only one element and queue front we are going to increment. So element in the first index we are going to delete. So the element 2 we are going to delete. Similarly, the next element when you are going to delete, this condition is also true. So size becomes 0 and the front is now incremented. So second item, the second index element, that is 3, will now be deleted or returned. Now you can see if I want to delete, this condition is empty condition will become false. It will be coming out of this particular if statement. So we cannot add any more element now. I hope you understood the algorithm for deletion also. Let us see how to get the front element from a queue. So what we are going to do? We are going to increment front by 1 and just return the element. So it is possible only when the queue is not empty. So if is empty condition is true, then we are going to return the element. So only the element will be returned. It will not be deleted. The element will not be deleted after the execution. The value 1 will be printed. That's all. Let us see the program segments to understand it properly. So the first program we are having is full. If we are having rear is equal to maximum -1, then we will be returning 1. Otherwise, we are returning 0. The next statement is empty. If front is equal to rear, at that time we will return 1 to indicate the queue is really empty. Otherwise, the queue is having some element. The next is get the front. So the front will be increased by 1 and the whatever element we are getting, we are going to return that particular element. That's all. The next operation is delete. If is empty is true, then we are going to decrease the size by 1 and we are returning the front element of the queue. Similarly, for addition of the element, we are taking a if condition. If is full is true, then we are entering the element in the rear and increase the size by 1. So this is the whole thing that we are having for a cube while implementing it with the help of an array. I hope you understood it. If you understood the total process, give a thumbs up and share among your friends. In our next video, we are going to discuss about how to implement a stack using linked list. So see you then. Take care. Bye.